I bought this clock recently. It's one of those mechanical digital flip clocks, so that used to hang in railway stations and airports. This one actually came from Turin airport. I got it in the market in Turin I was at recently. It wasn't working when I bought it, but I managed to get it working, which I'm quite chuffed about. I think it looks great. If anything though, the view on the outside is only surpassed by what it looks like on the inside and the mechanism that drives it. So I'll show that. This is what it looks like on the inside, and it's great, isn't it? All mechanical. First thing to say is it's not actually a clock. There's no clock mechanism in this. It's known as a slave clock, and the wire you can see here runs to a control box, that's the one I've got here, which is the timing unit, and that provides a pulse every minute, which turns over the minute hands, and it's that pulse, only 24 volts, so it's quite tiny. And if I press this button here, it moves it on. That's an automatic one. Now if I press it again, you see it's an alternating current, so on one side and then the other side. Anyway, so this will be connected up in this case Turin Airport, and there'll be lots of clocks like this connected to a single control unit, so that if they wanted to change the time, they just change the time on the control unit, and all the clocks in the airport changed at the same time. So this is the power unit. Coiled wires, there's a magnet in there, and every minute the control unit supplies a pulse, and that moves the magnet round. There you go, moves the magnet round and drives this through 180 degrees, and that moves this cog on one move. And there's 10 cutouts in the cog, which is the 10 minutes. So every minute that flips around, and that moves on. Oops, I'm going to reset it. That moves on the minute display here. That occurs every minute in the pulse. There you go. At the top of the minute display, you've got this cam. It's called a snail cam. It gets fatter. So each time it moves around, it pushes this rod with the red dot further along. At the end of that rod, there's a hook. I don't know how well you can see that. There's a hook, and that's pushed along, and the energy builds up in that spring, such that when this cam moves around, there you go, that clicks back, and that pulls the 10-minute marker on one rotation. So that's how the minutes is driven by the cog here. The 10 minutes is driven by this little cam and spring arrangement up here. As well as turning the minutes and the 10-minute marker, this cam, this control also moves this snail cam here, which moves this rod along, and that moves the hour hands. And this cog here has 24 cutouts in it, and each minute this is moved along slightly, imperceptibly. If I move it on, you can see it changing. So I move it on, tiny moves. Over an hour, this cam here moves round, and when it gets to that point there, it'll flick back, and that will pull the whole thing back. You saw the cog was at the end of the 24-hour rotation, and then the whole thing gets moved on by to 000, which is going to happen in 6 minutes' time, I hope. As I say, when I bought this, it wasn't working, but I think I've set it up right now, and I haven't tested it on the full going over the 24 period, but I think it's all right. When I first had it, like it was the hours were changing on the 16 minutes, and it would go to kind of like 25, 30 and stuff like that, and that was kind of making no sense. But I think I've got it now. So and you'll notice actually, for those observant, it's moving more than every minute. It's actually moving every 30 seconds because the impulse from the little unit I've got is pulsing every 30 seconds. And I need to change that. I need to get one that pulses every minute. But anyway, it's working. It's just going twice as fast. So so that drives that cog round there. That drives the hours, and then up here you've got another snail cam, which moves on the 10-hour displays, because every 10 hours that one flips over. But that you see that's moves every 10 hours, it flips around, and it only does that 3 times, then it completely resets itself. So it's 0, 1 and 2, and then completely resets itself, which is driven by a mechanism behind the plastic cog in there, which is another cam. You can see is just working up itself to a big drop, which is where the energy comes from for the whole thing. What is neat about this is it all runs off just 24 volts. It's, look at it and think there must be a lot of power to drive those things round. But it's not that much. So each time a little bit of power, this clicks on, energy is stored in there. That tightens that spring a little bit. Same here. It tightens every hour, a little tighten of this spring, which pings over every hour. And then up here, every 10 hours, you've got some more energy in that spring that gives enough power. So we're getting close to it pinging over. Okay, here we go. Should be clicking over. If it's working properly, should show 0, 0, 0 in a few seconds when it pulls it over. If it's set up, if I've set it up right. So, when's it going to go? Oh, it works, it works. It's kind of like the sound of commuting. For those who remember commuting in the, I don't know, 80s, with the big boards at railway stations and airports, that was all the same technology. It's clapper boards, all digital now. Proper digital rather than mechanical digital, like these things. But it's kind of the sound of commuting to me. Anyway, that was fun.